Welcome. In this video, I'm gonna teach you. I'm gonna show you my a Python script. Uh, so let's open idle. So here we have the shell. So I'm not gonna use the shell. So I'm gonna use a module. So I'm gonna create a new file. I'm gonna save it. Save it where? I'm gonna save it here. And I'm gonna call it finding square root. So finding the square root using Arcadia, using ancient Greek algorithm. Okay, let's see. So let me see if I find the one that I want to use. Okay. Okay, it's not this one. Alexandria, I think it's called Alexandria. Alexandria. Well, anyways, so the way that we're gonna do it is as follows. Okay, so let's see. Let's see if this gives us an option to do special comments. Let me see. Comment. Okay. I don't see it. So what I'm gonna do, so let's see. So see, this is my first time writing one of my, I haven't written Python in a while. Let's look at how things work in Python. So comments in Python. So I'm teaching you how I would start practicing Python program. Okay, so we're gonna do. So first, I suggest you write your name. Then I always try to be detailed. So on the date, I'm gonna put 6/20/5/24, and what I'm writing about is finding algorithm to find the square root. Okay. So the algorithm that I'm gonna be using is as follows. So I need a okay. I need a guess variable. I'm gonna call it G guess. I'm gonna call it G guess bar. Let's call it guess bar, yes. Then I'm also gonna need I'm gonna call, I need an initial guess for the square root of a number. So I'm gonna call it the initial guess and call it init guess bar. Okay. Okay, so that's what I need. So I'm gonna, let's see we can do this like this. So guess bar equals, so let's say I'm trying to find, I need to find the square root of 69. So my initial guess is gonna be equal to 12. I call it 12.5. And I'm gonna call, I also need my tolerance level. So I'm gonna call it tolerance, I'm gonna call it tolerance, just tol. Okay, so guess variable, okay, for this one, I'm going to the tolerance. So I want, the tolerance is used to compare the exact answer with the guess answer. So I'm gonna give the tolerance to be 0.001. Okay, so the guess variable, I'm gonna call it 0 at the beginning. 0.0. Okay. Okay, so my initial, so the guess variable holds the initial guess holds initial guess. This one tolerance. This one answer. The answer. Okay, and then so I think I'll do this one a little different. So my tolerance, I'm gonna call it 69 because that's and instead of tolerance I'll call it root, so that way I know exactly what I'm talking about. So root, and instead of tolerance I'm gonna do also need my root. So root, I'm getting root, okay, that would be root. So the square root of 69, so the root will hold 69. Okay. So let's make the first guess. Okay, so now of course we need a loop because a loop will help us find the square roots. Okay, so let's see how we do roots in Python. Loops in Python. From what I know, other languages, loops, you can do what you can do in a for loop, you can do in a while loop. So I believe you can do the same thing for Python, but I'm not entirely sure. I will cover that when I get to loops. But for today, I want to use a while loop. I like while loops. For loops are I like it when I have to go through iterations, but this one I'm just trying to compute stuff. Okay, so I'm gonna call it while. Okay, so while guess bar, so while my answer is less than or equal, or less than or equal to 69. Okay. So guess bar, let's call it guessed. Guess. Okay, see. Okay, 1 second. Guess, yes. Guess bar is equal to guess bar plus guess bar over okay, let's see. Finding, let's see, let's find the exact thing. Finding the square root ancient method. Okay, it is this one, look, the Babylonian. Okay, so let's call it Babylonian. So algorithm to find the square root, and then in parentheses let's call it Babylonian. Okay, so what it says is that you make an initial guess. So we're gonna call initial guess. I already have it here, so we already did this. And then okay. Okay, so the guess, looking at the formula is like this. We're gonna have to find I'm gonna make the first iteration, so I'm gonna call this one first iteration. In other words, first trial, first attempt. Okay, so that's gonna be guess bar is equal to init guess times init guess. So what I did here is the first attempt. So then to keep going, what I'm gonna do is I'm gonna use the algorithm. So I'm gonna do so here would be root divided by guess bar. And then in parentheses we're gonna divide it by 2. So we take the average of the previous iteration and root, the root we're trying to find, divided by the previous case. And we do that by summing those two quantities and dividing them by 2. So here we compute better approximation. Okay. Okay, so next step is gonna be, let's see. Of course, we need to see the answer. So, okay, so what I'm gonna do is print. So I'm gonna do print. What I'm gonna do is print iteration. Let's have a counter so that we will know what step we're in. Okay, so let's see. So we're gonna also need a counter, a loop counter. I'm gonna call it I. So the first, since we do an first attempt, I'm gonna call I equals 1. So now next attempt will be print. It will be iteration. And then, so we print the iteration counter I, and we we're also gonna do is gonna print gonna call it root approximation. We're gonna okay. Let's see what we get. Let's see if we get any errors. Okay. So we have to increase the counter as well. So let's see. Let's see why we're not getting our answer. Let's see. Restart. Okay, maybe I have a different. I need to put the let's see if even we have, okay, so initial guess, okay. Okay, so we need to convert the convert each number into string. Now let's see, we're gonna do the same thing here. So let's replace it here. Okay, so first root, okay, so we're gonna need, okay, that's the first correction. Okay, now it looks better. So what I did is 12.5 times 5. Okay, let's see. Okay, so now you can see 12.5 times 12.5 give us 156. So that's a very, very bad initial guess, because look. So I would suggest you pick something, you restrict your initial guess to less than the actual root to make any sense of this. So less than 69. So let's call it actually, sometimes they even go even further. What they do is that you need to be something a small number. You can start with a small number like 5.5, something that is below 5.5 times 5 is 25. So let's start with 5.5. Never choose something that goes beyond the root. That will multiply, will give you beyond the root. So let's call it 5.5. Now let's see. We save it and we'll run it. Okay, I'm gonna kill it. Okay. Okay, so what I was noticing is that I was getting close in some. So if I multiply 8.30 times 8.30, I get almost 69. So I was getting a good answer, but since it's still less than 69, it doesn't stop. So what I'm gonna do is I'm going to make a restriction to how many decimal places I want to or how many iterations I want to use. So I'm gonna use less than, So I'm going to use I less than 100. Okay. Okay, so let's run it. Okay, so if I run the algorithm for 100 iterations, so I start with the first iteration is 30. First iteration approximation 30. Second 16, 10. So the closest it gives me is 8.3066. So one way to test this is that if we have the right answer. So the first iteration, 8.5.5 times 5.5 gives us this. Okay, 30. Okay. The second iteration is this, all the way to the 100th iteration. Okay, so I'm gonna copy it and I'm going to multiply it by itself. And what I get is 69, very close to 69, which is the root that we're supposed to be getting. So we did get a good algorithm. So notice what we did. We created an initial guess. Okay, we specified the root we're trying to find. We specified the guess variable, the iteration counter, so we can print statement. So first we make the initial guess, we multiply the initial guess by itself. Then we do a loop where we restrict the iteration to less than 100. We specifically say that the guess bar has to be less than 69. And then we compute and we do the algorithm, which is we assign the value to the guess bar equal to, so in other words, we take the average of the previous guess plus the root, which is 69, the root we're finding, divided by the guess, the previous guess, and we divide it by 2, so that takes the average. And we keep doing this until we find a better approximation. But we restrict it by saying less than the iteration less than 100. You can go more to get a better approximation, but if you do that, the algorithm will stop. Sooner than just keep going. So thank you very much. Don't forget to subscribe, please.